Have you ever wondered who really builds the digital world we live in? It's not just one person, it's a team of specialists. And today, we are opening the playbook to one of the most in demand and evolving critical roles in tech today. Welcome to DataSurface, where we break down complex data topics into clear, career ready content. In this video, we will dive into the world of data engineering roles from the legacy systems of the past to the cloud native specialist of today. Let's see quickly what we will cover today session. We'll start by understanding the evaluation of data engineering, look at the foundational legacy roles, and then dive deep into the 5 specialized data engineering roles that are in high demand right now. By the end of this video, you will have a clear picture of where you might fit in. So let's jump in. The evaluation of data engineering. So to understand where we are today, we have to know where we came from. Right? The data engineering didn't just appear in overnight. It's evolved through the two major eras. Right? It's all started in the traditional warehouse era. The world was simpler then. Companies deals with the structured and predictable data, and the main goal was to generate business reports. The classic workflow that powered everything was ETL. That stands for extract, transform, and load. You pull the data and clean it up and then load it into the data warehouse. This was the backbone of the data systems for years. And the person who managed this entire process was the legacy warehouse engineer, or you can call as a data engineer who works on legacy systems. Right? These were the original data architects. Their life was about developing batch ETL jobs, and they'll design star and Snowflake schemas in legacy data warehouses. These are the data modeling techniques, and they'll build the reports for BI. And if you look at the key tech stack, what are by these people, mostly legacy technologies like SQL, Informatica, Oracle, Teradata, these are the data warehouses, right? So they mostly work on this tech stack to build reports for the business, right? But then the internet exploded. Suddenly we had a big data, unstructured, messy and massive, right? The old systems couldn't handle it. This gave rise to the Hadoop data engineer. So the Hadoop era started. For a decades, this Hadoop data engineer also is having a good time, but it was a decade back. Their world was all about distributed computing, using clusters of computers to process enormous data sets. They used tools like Hadoop, MapReduce, Hive, and Spark to make it all work, right? So this too comes under legacy tech stack. So initially, the legacy warehouse era started. That's where the data engineers use the legacy data warehouses like Oracle, Teradata and all. Then there is a limitation with the legacy data warehouses. Like those warehouses is mostly deals with the structured data. But the data evaluation has started, and the data volume is grown like anything. Post the internet evaluation started. That's where this Hadoop era started. But later point in time, the maintenance of this Hadoop ecosystem became quite expensive. Right? Maintaining those huge clusters was complex and expensive. So the world shifted again, this time to the cloud. Right? So that's where the modern era started. That's when everything changed. And with it came a new, more flexible workflow, ELT. We'll extract the data. First we load the data into the data warehouse. Then we will transform the data, because we have supported compute power and storage, right? Like we don't have any limitations with those. With the cheap cloud storage and powerful cloud warehouses, it became easier to load raw data first and then transform it later, right? So that simple change revolutionized everything and gave birth to the specialized data engineers we see in today's data world, right? So let's meet those specialists. We'll start with the master of the cloud itself, the cloud data engineer, right? So this role is all about building and managing data solutions on cloud platforms like AWS, Azure and GCP. So in the market, we have 3 most popular cloud platforms, which are AWS, Azure and GCP, right? So when we are talking about this cloud engineer, so they mostly build on cloud native pipelines and they'll automate the infrastructure. So they mostly work with any one of these cloud platform. Tech stack, it could be either AWS or it could be Azure or it could be GCP. So Like if you see inside this cloud engineer, you can take a step down and you can see most popular data engineer roles. You can categorize a 3, each one for one platform. AWS data engineer, the person who is having core competency in AWS space, they have good knowledge about the core services in AWS cloud platform, they can become cloud AWS data engineer. If the person has a strong knowledge in Azure space, Azure cloud platform, like ADLS, Synopsys, Azure Data Factory, Databricks, they can become Azure data engineer. If the person is interested or he has a mastering skills in GCP cloud platform, like a cloud storage, GCP buckets, BigQuery, which is a GCP data warehouse, data flow, and cloud functions, they have solid knowledge on this particular core services from the GCP side, they can become GCP data engineer. So these 3 ultimately comes under the cloud data engineer roles. Now move on to the next one, pipeline engineer. We have the most common role you'll see today, the backbone of the modern data stack. Their entire focus is on designing, building and maintaining the data pipelines that feed the entire company. They'll develop ETL, ELT pipelines to fuel the data to the organization. Coming to the key tech stack, you can see the toolkit is packed with essential like Python, SQL, Apache Airflow and Spark. So I have segregated for each data engineer language wise and cloud platform wise and what are the core concepts and tools. You can able to see in the screen. I am not going to touch in each and every box because it is a kind of a self-explanatory. That's where I'm going to put one concluded one as a tech stack. So I'm keep on touching the tech stack and I'm referring. So the tech stack is basically it covers all languages, cloud platforms, infrastructure, everything will cover. So our primary focus here is like we'll see what are the demand engineer roles are available in the data engineering space and what are the required tech stack for them. So that we have a clear picture, we can plan accordingly and we can move towards our goal. Right? Now we'll move on to the next data engineer role is streaming data engineer. So what about data never stops? That's where the streaming data engineer comes in. They are specialists for real-time streaming data. Like pipeline engineers, mostly they build the batch jobs. But whereas if you are dealing with live streaming data, that's where these streaming data engineers coming to the picture. They build systems that process massive streams of data in real time from things like social media feeds or financial transactions. They build systems to process real-time events like ride tracking, stock trading or app analytics and all. Right? They use powerful tools like Apache Kafka, Flink, Spark Streaming, Scala, Confluent. They will use these mostly streaming related tools as their tech stack. Right? Now move on to the another most demand role is analytics engineer, who makes all this data useful for the business. So meet the analytics engineer. This is one of the newest and fastest growing roles in today's market. So they are the bridge between data and data analysts. They take the raw data and transform it into perfect, easy to use models for reporting and analytics. Their role revolves around SQL, Python, most importantly Snowflake and DBT along with BI tools like Power BI, Tableau. So these are their key tech stack. And finally, we have the role that powers AI, the ML data engineer, also known as the MLOps engineer. So they build the specialized pipelines needed to train and deploy machine learning models, managing everything from feature stores to model monitoring. Right? So they work with the Python and the suite of ML or AI all libraries. So I hope by the time under data engineering space, what are the key specialist data engineering roles are available in the market and what are the tech stack which is required or relevant to that particular data engineer role. Right? So before we wrap up, there is something important to notice. Across every role we just explored, whether it's a cloud, pipeline, analytics, even ML, one platform showing up again and again in the world of data engineering, which is Snowflake Cloud Data Platform. So it is started as a cloud data warehouse, but today Snowflake is evolving into complete data platform supporting everything from data pipelines to machine learning, along with solid support of SQL, Python development with Snowspark, real-time dashboards, secure data sharing, and even generative AI-powered assistants through Snowflake, Cortex, and many more. It integrates deeply with modern tools like dbt, which makes transformation in the cloud incredibly efficient, transparent, and scalable. So the beauty of the Snowflake Kit is supports all three major cloud platforms. And also what makes Snowflake so powerful is how it brings people and tools together. So the data engineers, analysts, and data scientists can all work in same place using the same data without complex handoffs or technical gaps. So you are building a feature in data learning. Snowflake isn't just a good idea, it is a modern advantage, and it will add a lot of weightage for our curriculum as well. By the way, if you are curious to explore more about Snowflake and dbt, how it fits into all of this, check out dedicated playlist right here in the data surface. Have a look at once. So there you have it, from the foundational legacy roles to the specialized cloud experts of today. So don't ask, should I become a data engineer? Ask yourself, which role is perfect for you? Where I belongs to this ecosystem? Right? And as a bonus tip, if you are feeling completely lost about where to start, where to go, and how to land your first opportunity in the data engineering space, don't worry, you are not alone, and it's a more approachable than you think. So here is my personal suggestion. Especially if you are aiming for the analytics data engineering path, start with SQL. It's the foundation of everything. Once you're comfortable with SQL, you can move on to the tools like Snowflake and dbt, which are built around SQL workflows. The best part, you don't need to learn any complex programming language right away. Both Snowflake and dbt are in high demand across modern data teams. So learning them early can open up more job opportunities and give you strong edge in the market. Of course, this is my just opinion, not a fixed rule. But if you are overwhelmed, this could be a great way to start your data engineering journey with confidence. If this playbook helped you understand the landscape, make sure hit the like button and subscribe to Data Surface for more deep dive into data carriers. In upcoming video, we are going to deep dive about the analytics data engineering toolkit. So please stay tuned. Let's build your feature in data one video at a time. With that, signing off. Thanks for watching. We'll meet you with another interesting topic in next week. Till that time, take care. Bye bye.